welcome to nuclear chemistry. Nuclear chemistry involves the nucleus of the atom. Keep in mind that this will mainly be focusing on changes in protons and neutrons in an atom, not so much electrons. You've heard of radioactivity before. Radioactivity is the process of nuclei emitting particles and rays. Keep in mind, particles are actually matter, and rays are just energies. They actually have no mass. Emitting, remember, means to give off. So in this unit, we're going to talk about nuclei actually giving away particles and rays. Why might they do something like that? The reason that this happens is because of nuclear instability. An important term to keep in mind here is the term isotope. Remember, an isotope, or isotopes, are atoms, that have the same number of protons and a different number of neutrons. Because they have the same number of protons, they're going to be the same element. The different numbers of neutrons give them a different mass. Famous example is carbon-12 versus carbon-14. Both carbon, because they both have 6 protons, carbon-12 only has 6 neutrons, or carbon-14 has 8 neutrons. And those 8 neutrons actually make carbon-14 unstable. The most important ratio when it comes to stability is the number of neutrons to the number of protons. This ratio isn't fixed for any given atom. We'll talk about this. Some atoms actually need more neutrons per protons than others. Just a little quick background for you. Henri Becquerel originally discovered radioactivity. He worked a lot with Marie Curie and her husband Pierre. They actually did a lot of experiments with an element called radium. There are more than 1,500 known combinations of protons and neutrons. Of those that are known, only 264 are actually stable and don't decay over time. So what this actually means is there are 1,500 numbers of neutrons, protons you can have in combination, but only 264 of them are actually stable and don't radioactively decay. Henri was actually putting pieces of uranium in the sun to kind of charge it up, if you will. And then he would put it in a dark room, and he would put some photographic paper near it. And the uranium would actually develop the photographic paper. So it was spontaneously emitting particles and rays. He actually thought that it was actually storing up the sun's energy and re-releasing it. One day on a day where there wasn't too much sun, he got the exact same result with this piece of uranium and found out that that was actually a spontaneous emission. They actually were the ones to coin the term radioactivity. They actually discovered that uranium ore has 2 other elements in it, polonium and radium, and they did some extensive experiments with these elements. So they named what they saw radioactivity. And radioactivity is the result of a nuclear charge called a transmutation. A transmutation is a change in the nuclear composition, or in the nucleus, of an atom, which results in a different element. So we're going to look at transmutations in this unit, and what you will actually see is that some elements actually give away different emissions, different amounts of particles that completely change the identity of that atom because the nucleus has a different content. So we can actually have a different number of protons, thus making it a fully different element. There are 2 major types. There's natural decay. This happens spontaneously in nature, such as carbon-14, radioactively decaying in nature. We can also bombard one one atom, or I'm sorry, one atom with another or with a particle and cause an artificial or man-made transmutation. This is how actually man-made elements are created when you think about things like particle accelerators. So there are four major categories we will be talking about. There are natural transmutations, artificial transmutations, and there are kind of two subcategories, something called fission, which is a type of, So fission is actually a type of an artificial transmutation.
Brian Nichols, please call the main office. Brian, call the main office.
And fusion is a transmutation that actually does occur in nature. Humans have actually tried to, do this as well, so to try to make this a man-made process as well. So some great moments in science. These a lot of the discoveries of the parts of an atom were because of exploration into nuclear chemistry. So Rutherford, the guy who's flung the alpha particles at the gold foil to see what was going on inside of the atom, actually also took alpha particles and he flung them at a nitrogen-14 atom. And what he actually found, if you add the number 4 from the top here to the 14 here, you get an 18 on top over on the other side. And if you add the 2 and the 7, you get 9 protons on the bottom. So we actually get an isotope called fluorine-18. Fluorine-18 is an unstable isotope. So what he actually discovered is by letting that fluorine-18 sit around, the F-18 actually broke apart into oxygen-17, and it also gave off a proton. So this is actually, the second step is actually a natural transmutation that occurred as a result of the fluorine-18 being made in a artificial transmutation. So what's kind of cool about this is actually how the proton was isolated. Chadwick is actually really famous for discovering the neutron. This was a really big deal. Since neutrons don't have a charge, it's very hard to do experiments with them. So Chadwick took an alpha particle also, which is sort of like the helium nucleus, and he bombarded some beryllium-9, thus making carbon-12. And this little particle with some mass, but no charge was spit out, and we now know that to be the neutron. So these were actually really important experiments that really helped us to know what we know about the atom today. Certain elements do love to transmutate, specifically what are called transuranium elements. Any element with an atomic number greater than 92 is considered a transuranium element. They all undergo transmutation. They do not occur naturally, and they are all radioactive. So if you think about hearing about particle accelerators and Glenn Seaborg and really famous people in Berkeley, California, making different elements, the elements that they're making, the ones that are above 92 past uranium, so such as neptunium, plutonium, americium, those are all man-made elements that do not occur at all in nature. So they actually all have to be made in a particle accelerator. And a lot of these have been made beginning in the 1940s when neptunium and plutonium were first made.